Derivative of logarithmic functions. Let's recall what is the logarithm. If we have y equals the natural log of x, the equivalent statement is that the e to the y, or x equals e to the y. So now we know a little bit about implicit differentiation. So remember what we tried to do, we tried to find the derivative of the natural log of x. So in order to find dy dx, we can now take the derivative of this side here. I'm going to say that by implicit differentiation, and that's a long word, differentiation. Need to count how many letters in it, but if we take the derivative d dx of x on the right side, on the left side, equal the derivative on the right side, then this gets us to the following. We're going to get from here that 1, the derivative of x, equals the derivative of e to the y. Well, we know that it's going to be, if we derive it with respect to y, it's simply e to the y, and then we have to have the derivative of y with respect to x, so dy dx. So this gives us a solution to dy dx. We're going to say that dy dx is equals to 1 over e to the y. But what is e to the y? E to the y is x, right, by the definition of the logarithmic function. So it's 1 over x. So this gives us the famous differential rule for the logarithm. D dx of the natural log of x is 1 over x. I think somebody asked me on Wednesday, what is the derivative of the natural log? So there you have it. Yeah? What about different base? What about if you have, so this will be point number 1. Point number 2, the next point, let's say that y is a different base. This is the base e, the natural log, but if you have a generic base, let's say a base b of x, how we find its derivative? Okay, we need that too. So again, I'll go to the definition of the logarithm, and what is the statement here? It's the same as b to the power of y equal x, so x equals b to the power of y. Remember, the logarithm returns the power of the exponent. So now, again, implicit differentiation, so we'll do the same treatment, d dx of x on one side equal, this time I'll split, and I'll say it's equal to d dx, and on the right side we have b to the power of y. So we get 1 on the left, and on the right side we have b to the power of y. What the heck is that? Okay, but we saw it already. Remember what is the derivative of b to the power of y? It's the natural log of b times b to the power of y. If you do the chain rule, that's how. We did it when we learned how to do the chain rule. Okay? And then we need to take the derivative with respect to x, so it will be times dy dx. So, turn out that dy dx by itself, as before, will be 1 over natural log of b times b to the power of y. But what is y? Y is the log base b, right? So we need to do a little adjustment here. And since b to the power of y is x, then we end up having 1 over natural log of b over x. So here's the other rule for the logarithmic function. This is the generic base b, and b normally we're talking about the standard, the common log. It will be log 10, log base 10. So b will be 10. The derivative will be 1 over, the natural log of b times x. So if b equals 10, if we're talking about the common log, then the derivative of log x will be 1 over natural log of 10x. I'll give you a quick example here. So this will be example 1. If we want to find the derivative of y equals natural log of square root of 5x, like so. By the way, let me box it. This is a rule as well. So we don't need to reinvent the wheel every time we see one of these two forms. We know exactly where to go. But let's look at this case here where we have the natural log of square root of 5x, and we want to find the derivative. So find y prime. Okay. Well, we'll have to use the chain rule. We're going to say that y or u equals square root of 5x, and therefore du dx equals square root of 5, and y equals the natural log of u, therefore dy du will be simply 1 over u, and then y prime would be the product of these two, so it would be 1 over u times square root of 5, so it will be square root of 5 over u, but what is u? Square root of 5x. So it's 1 over x, the solution. And now wait a second. You need to ask yourself, so what is the difference? If the natural log of x is the derivative of the natural log of x is 1 over x, and the derivative of the natural log of square root of 5 times x, let's put it in parentheses, is also 1 over x, how can it be? Well, there are two ways to explain it. One, to realize what is the derivative. The derivative gives you the slope of a tangent at any given point. So what is the difference between these two functions, the natural log of x and natural log of 5x? To examine the difference, what we can do is look at the property, the logarithmic property. So here's the question. Let's ask this question. Is it possible that the derivative of the natural log of x, like so, is the same as the derivative of the natural log of square root of 5x, right? Or in general, I think I misplaced the comma, or in general, I'm going to generalize it. I'm going to say, okay, what happened instead of square root of 5, I have some generic coefficient k. So the derivative of natural log of x, is it possible that it's equal to the derivative of the natural log of kx, like so? Okay? So the answer is yes. Okay? The proof is the following. If you look at the natural log of kx, right, Remember that rule, I'm sorry, the parentheses are misplaced. The natural log of the argument kx, the logarithm of a product is the sum of logarithm. Remember that rule from algebra? Okay. So it will be the natural log of k plus the natural log of x. Now take the derivative of the natural log of kx, like so. Then take the derivative of the natural log of k plus the natural log of x, right? It will be the derivative of natural log of k plus the derivative of the natural log of x. But natural log of k is a constant, is a fixed number, and the derivative of constant is 0. So you end up 0, and the derivative of natural log of x is 1 over x. So here's the proof that it is the same. So we have another rule to add to the previous two rules, and we'll do it on the next page. And the rule is the following: d dx of, let's do a constant. Normally we apply the numbers, well, let's k. We use k, so we stay with k. The natural log of kx is also 1 over x. So we have three rules for the derivative of logarithmic functions.